Hey guys, this is Mrs. Keith, and we're going to now do notes over the in-class practice for the chords, secants, and tangents. So using what we learned in the notes, we're going to apply that here to this in-class practice. Okay, so first thing I'm going to do is figure out what arc EF is. That would probably be helpful. So I'm going to do 360 minus 250 minus 55. And when I do that, I end up getting that arc EF is going to be 55 degrees. So if that's the case, these two arcs are equal, which makes these two segment lengths equal, or those two chords. So x equals 8. So that was pretty easy. You might try these in-class practice problems on your own and then come back and see what you got right. And if you need help by watching the video, that might be a good idea. Or you can just work through these with me. So just an idea. All right, on the next one, we have a kind of crazy looking circle here. We have some chords. We don't have any diameters drawn, but we do have a radius. This 20 right here is my radius. So I'm going to use that radius to help me find segment lengths and parts. My goal is to find the length of AB, so I've eventually got to make it drawn over here to segment AB. Well, the first thing I'm going to do is notice that if I draw another radius right here, I've created a right triangle. Again, that radius length is 20. And so I can use Pythagorean theorem to figure out what this length right here is. So we're going to do 16 squared plus x squared equals 20 squared. So when I do that, I end up getting x squared equals 144. And so x equals 12. Now this picture is definitely not drawn to scale. But so if this is 12 right here, we now have this whole length for this segment right here is 15. So let me mark that that's 15. So now I'm going to draw myself another right triangle going this way to B. So again, that radius is 20. So now we've got a right triangle right here where we've got that this side is 15. We've got the hypotenuse is 20. So now I can do 15 squared plus b squared equals 20 squared. That's 225 plus b squared equals 400. So b squared equals 175. And when I take the square root of that, I get the square root of 175. Now remember, that's the same thing as the square root of 25 times the square root of 7. And so that's just going to be 5 square root of 7 if I were to simplify it. So actually I shouldn't have boxed that in. That's saying that this length right here is 5 square root of 7. So if I were asked to find the length of AB, it's going to be 2 of those, so it's going to be 10 square root of 7. So that would be my answer if I kept it exact. If you wrote it as a decimal, it's 26.458. Okay. So again, what you're trying to do is just make a right triangle with the radius drawn to a chord in order to create a right triangle so that you can use Pythagorean theorem. Okay, on the next one, we have M as the center, AM is 9. So this AM right here is 9. That's the radius, so that's helpful. I can draw another radius right here, which is also going to be 9. And I'm going to use it to help me find x. Well, I know that this arc right here is 60. Well, I also know that this is a central angle. So that angle right there is also 60. So now I've got a 30, 60, 90 triangle. So I'm going to redraw it over here. So if this is 60, this will be 30 because that's a right angle there. I know that this is 9. Remember your rules for a 30, 60, 90 triangle. So the side across from the right angle is your 2x. The side across from 30 is x. And then this is your x squared root of 3 side. All right, so that being said, I know 2x equals 9, which makes this side over here 4.5, or 9 halves. And then this would be 4.5 square root of 3. So x is what we're looking for, which is that bottom side down there. So that'll be 4.5 square root of 3, if we kept it exact. All right, on the next problem, we have 2 segments drawn inside of a circle. So there are 2 intersecting chords. So you've got this segment here. Its parts are x and x. So we're going to do part times part equals part times part, since the segments are intersecting inside the circle. So we'll do x times x equals, on the other segment right here, my parts are 4 and 9. So 4 times 9. So when you multiply this out, x times x is x squared. I'm going to write that better. Sorry. So x squared equals 4 times 9 is 36. And then we'll take the square root in order to solve. So x equals 6. And that's my answer. All right, let me scroll this up. Okay, on this next one, we have this chord right here that's 20. Now we've got a portion of a diameter drawn perpendicular to that chord. So that means it breaks it up into 2 equal parts. So that's 10 and 10. We're also told right here that AB is 26. So that's the diameter, which means each radius is 13. All right, now we can use Pythagorean theorem because we have a right triangle right here. So we can do a squared, which is x squared plus b squared, equals our hypotenuse squared. Our hypotenuse is always across from that right angle. So we get x squared plus 100 equals 160. Whoops, I don't know what I'm writing. Equals 169. Subtract 100 from both sides and we get 69. So x is going to be the square root of 69. Or if you got a decimal, it would be 8.307. All right, on the next one, again, we have chords intersecting inside of a circle. So you've got this chord right here. Its parts are 5x and 6x. So you're going to do part times part equals part times part. So 5x times 6x equals, on the other segment, we've got, this is our segment and these are our parts. So we'll do 10 times 12. So multiplying this out, we get 30x squared. Don't forget, when you multiply x times x, you get an x squared. And then 10 times 12 is 120. Divide by 30, and we get x squared equals 4. So take the square root of that, and I'm going to get x equals 2. And that's my answer. All right, let's move up. Okay, on this one, we have segments intersecting outside the circle. So we're going to do, I'm going to write this out. We're going to do outside times whole equals outside times whole. So in this case, the outside is 4. The whole length will be x plus 4. On the other segment, our outside is 5, and the whole length is 10. So distribute the 4, we get 4x plus 16 equals 50. Subtract 16 from both sides, and so we get 4x equals 34. And then when you divide 34 by 4, you're going to get 8.5. And that's your answer. All right, on the next one, again, segments outside of the circle. So you're going to do outside times whole equals outside times whole. So on this segment, the outside part is 5, and the whole length is x plus 5. And then on the next segment, this one right here, the outside part is 7, and the whole length is also 7. You know what? I probably better move that over. So we've got outside times whole equals outside times whole. All right, distribute, we get 5x plus 25 equals 49. Subtract 25 from the 49, and we get 24. And then when I divide by 5, I just get 24/5 if I want to keep it exact. If you got a decimal, it would be 4.8. I guess that's also exact when since it didn't need to round down from there. Okay, let me do the next one. Okay, on the next one, again, we're going to do outside times whole equals outside times whole. So the outside part is 4 times the whole length is 6 equals, on this one, the outside part is x minus 3. And then the whole length, I'm going to show my work, is x minus 3 plus x minus 1. So when we multiply that out, we get 24 equals, I'm going to simplify that. That's x minus 3. And when you simplify this, it's going to be 2x minus 4. Okay, now we need to multiply that out. So I'm going to do 24 equals x times 2x is 2x squared. I'm gonna show work again. So x times a negative 4 is a negative 4x. Now I need to multiply negative 3 times everything. So that's going to be negative 6x and a positive 12. Okay, so simplify some things. We get 24 equals 2x squared. Those two combine to be a negative 10x plus 12. I'm going to move the 24 over because I have an x squared. It has to be equal to 0. So I'll subtract that. Okay, at this point, it would be a lot easier if I divide everything by 2. So that's going to give me x squared minus 5x minus 6. Now I can factor that. So that's going to be x minus 6 times x plus 1 equals 0. All right, now we can solve that by setting each factor equal to 0. So x equals 6 or x equals negative 1. Again, x up here, if I plug in that negative 1, I'm going to get a negative segment length. So that one I can ignore, but this will be my answer for that one. That was a long problem. Okay, let's do the next one, number 11. I think my numbering's off on this, sorry. So on number 11, we have outside times whole equals outside times whole. So we'll do x times x plus 10 equals 12 times 12. Again, I end up writing outside, sorry. X times x plus 10 equals 12. I'm just going to say 12 squared. It's going to be, again, outside times whole times outside times whole. So that gives me x squared plus 10x equals 144. Now, because we have an x squared, everything has to be on the same side and it has to be equal to 0. So x squared plus 10x minus 144 equals 0. And then we're going to need to factor. So you're going to have two factors. We'll have x and x. And then this will factor to be plus 18 and minus 8. So x plus 18 equals 0 and x minus 8 equals 0. So x equals negative 18, which that represents a segment length, so we can't use that one. And x equals 8. So that's my answer for that one. All right, on this last one, we're going to do outside times whole equals outside times whole. So 1 times 4 equals x times x. So that'll be 4 equals x squared. Take the square root of both sides and I get x equals 2. And that's all of our examples for this one. All right, thanks y'all.